Hi everyone. So I wanted to show you this research from in Google. So what's Nexara Daniel's gross marking for 2026? And there's absolutely no information on this. And it's normal. I'm going to explain you why. So here I have the same request on using ChatGPT. Same thing. I mean, I think it confused with another company here. And that's normal because this company doesn't exist actually. But imagine you have this company and you have some internal documents and you want to find the information in those internal documents. This is where come up this AI research agent project, and we're going to use some technology to find the information here inside your internal documents. So now let's see how it works. So we're going to use this technology, basically, Agentic Core, the Serverless Cloud, and the front end. So in Agentic Core, we have LangGraph, Claude Sonnet with AWS Bedrock, and then we have Titan embeddings, FAISS vector store, and Tavily search for the web. In the server cloud, we have the AWS Lambda, the API gateway, DynamoDB, ECR plus Docker, and Terraform for the infrastructure as a code. For the front end, we have React and TypeScript. We have Tailwind CSS and CloudFront CDN, and then everything is stored on the S3 bucket. So why a normal chatbot can answer this? Well, because this is private documents, it's not exposed to the web, so we need something a bit different. And we can use an LLM model to find the information on private document too, but we can use this technology. What is an AI agent? So we have a plain LLM. So LLM stands for large language model, and is going to answer in one shot from memory and is confident even if it's wrong. There's also an AI agent, which is what we use here. We can take steps and use tool, check sources, and then answer. Yeah, so basically it's like a researcher who opens the filing cabinet before replying, so can find the information and then give it to you after. So what is Agentic AI? So it's an LLM that doesn't just answer, it takes action in a loop using tools until it can answer. So for example, you have the plan here. The first step is a plan. Then we use a tool, and then we observe, and then we go back to the plan, and then we use a tool, we observe until we reach the goal that we want here, and then we can send the answer to the user, basically. So this is what about Agentic AI. For this, the tools can be the RAG to find the information in the document, and we have also the web search using Tavily endpoint. Tavily just to search on the web, but it's through an endpoint. What is a LangGraph? So LangGraph is a framework that I really like, actually. Is able to build agent as a graph. And so basically you have different steps here. You have step 1, step 2, step 3, etc. And then what offer LangGraph, it's a state when we can keep the different information through the different steps, basically. So it's really useful. Why not just a string? In a context, the agent has to remember a thing between steps, how it all that memory matter. And just a string, it's no structure. You reparse text every step, so that's pretty difficult to do. Can't all list the documents, web result, the step log, and it's easy to override. or lose track of something. And as opposed to the state object, we have name field, query retrieve docs trace. This is actually what in my solution that I propose. And all rich data, not just text. Each step updates its part and it can be saved. A work chart you can run, so we can use retrieve, search, analyze, and finalize. Basically, this is what we were talking about just before. So the RAG, what it is, so let's imagine you have an open note to an exam and you can't memorize everything, so you bring notes, okay? And when you have a question, you're going to look through your notes and then see the relevant information and then give your answer. That's really great, especially if you have a lot of documents. You can't memorize everything because the LLM has context window that we call, and it's limited in size, so it's growing now, but still putting all the documents in a context can also cost a lot of tokens, as opposed to the RAG is going just to take the right information at the right place and use this information to answer. Pretty good technology. What is vector database? So it's like a GPS, but for meaning. So we have we store our documents in a vector database, and then we use meanings basically to get some point in space. For example, we have one word or one part of a text that means the same thing as another part, so synonym or something a bit wider if you want. So that's about similarity and meaning. Very useful in this case. So documents plus live web. So yes, we have a private documents here, private corpus, and then it's frozen in time. Basically, we execute the process once and is stored in the FAISS database, and to be able to retrieve the information later on user request. And then we have the live web. Well, nothing special here. It's just an endpoint to Tavily. It's going to search the information on the web if you can find. Claude blends both basically here. So we take the information from both and then we gather the information and then we give an answer. The solution runs only when asked, so this is pretty cool. So if nobody using it, it costs £0 or $0, €0, whatever, and it's on demand. So as it is a cloud function, a Lambda here, it's just execute when we need. So pretty efficient in terms of cost. We just pay per request. We have one command to execute to deploy the infrastructure via Terraform, and it's provided already. So yes, you can make it your, I mean, this kind of template that I provide. You can clone the repo and then change it as you want, and you can drop your own PDF, deploy using Terraform, and see how it works and modify it according to your needs, of course. So let's see the code now. The AI research assistant. So it's built in Python, and I'm going to show you just a few things, the most important thing in the backend. We have the agent.py here, and we have, so let's go to the bottom and see this create agent. So this is the first part I wanted to show you. So create and compile the LangGraph agent workflow. So we have the state graph here. It's instantiate the state graph, and we are going to add nodes here. So we can see all the nodes: retrieve, search, analyze, finalize, and those are the steps I show you before in the diagram. So, and then we have this add age, which links the different steps together, basically. So we're going to retrieve, from retrieve to search, and this is this line, to search to analyze, this is this line, and so on, until we end the process. And so that's very good. And then I'm going to show you this part that I really like it. This one, analyze node. So this is the one just before the last step. And we analyze and summarize using the local corpus plus Tavily web result. So here we got the result, and if there's no information on the web or nothing, no document, internal document, then we're going to return in the summary that message. Otherwise, we're going to execute the LLM request using AWS Bedrock. And here we go. We have the prompt here that set up all the rules that say we want to take the documents from the internal research corpus and the fresh web search result from Tavily. And these are the different rules here that are set up. So here we go, and then we just write the concise factual summary during both the internal documents of web result, and here we go, the summary, and we just return the summary here. And that's it. So this repository is available publicly, so you can download it and modify it as you want. It's just a base, but think about checking everything and customize as you want. Let me know if you have any question. Thanks.